Welcome to Summit 2012. My name is Bryce Johnson. I'm a build engineer with Atlassian. Today I'm going to tell a story about going from commit to customer, building a continuous integration and release workflow with the infrastructure to make it success. And the key word that I want to bring here is workflow. How do I look at continuous integration, not just from a beginning standpoint, but how do I expand now into making it a lot better, leveraging it into a release, and then finally, how do we make that happen with the right infrastructure? Some of the key takeaways that I want you to take away are: where do I begin with that continuous integration process if I'm just starting out with my company, or if I have a little bit of CI going? What are some of the things and ideas that I can look at to really improve and grow with my process? And even if you're an expert or you've got a lot of things going on, a lot of automation, a lot of automated deployments, how can I improve that workflow and be more efficient, especially with Atlassian Bamboo? I'm going to show a one way of bridging CI directly into a release process, and also to help you coordinate your releases, and how I accomplish this with JIRA. Spinning that around, how do I look at the infrastructure? How do I design infrastructure to make that happen? So what are the goals of a good build system? How do I manage that infrastructure, especially for a CI system at scale? And then finally wrap up with kind of our next challenge with product development at Atlassian. Because we're growing so fast, how do we really make our CI processes efficient? And we're going to leverage that with DVCS and a concept called team branches. So starting off with the workflow itself, let's design something here. But first, how about a few questions just to get us going? Would I like to, in my continuous integration, be able to run different builds in parallel? Do I need to aggregate the results of a number of those builds into one result? Do I want to deploy anything? Would I want to launch builds based on some higher parent build? And finally, what kind of frequency should I have for a given build? Because do I want all builds to be the fastest builds? Do I need them to be? And if all builds are fast, that means maybe they're going to have some contention. So do I want that? Looking at kind of a generic design inside Atlassian, especially with JIRA, this is what we have. This is what we want to do with our CI process. It all starts with, of course, a commit, a change into the JIRA product from a developer. We then want a core set of CI to run. Our functional tests, our JUnit tests, our Selenium tests. This is our immediate feedback for developers. This is what they want to look at. This is where they want to go to see whether or not they broke the build. We don't want to really stop there, though. We want to be able to take this information and still leverage it and still use it, because we want to run the same tests against all of our supportive platforms. This is the databases that we're supporting for our customers, the operating systems that we're supporting for our customers. We want to be able to do some performance builds, and we want to make sure that some of our important core plugins are still not broken with the changes that have gone into the system. Now we have the inner loop CI for the developer feedback. Now this set of builds we don't need to run on an immediate basis. What they're doing, what we want them to do is be able to show us and pinpoint us is if something goes wrong here, that this is an actual problem with the database, the platform, the operating system, or a performance issue. So we want to be able to run the same tests again that we did in inner loop CI that have passed with that specific revision, and be able to determine what exactly is going on here. Now when we have this information and all of these builds have run, as kind of a release engineer, a release coordinator, we've really got a good idea of whether or not JIRA is ready to kind of now be consumed by a customer. We've run so many automated tests through our different platforms and through CI that it's getting to kind of be that we're ready to go with this product. But we're going to do one final step at Atlassian. We're going to actually dog food this. Okay, we're going to install this to a production system internally first to get the proper soak time from real users. So for the over 400 people currently working at Atlassian, they all hit an internal JIRA instance to make sure that it's ready, or as ready to go for customers as possible. And finally, then we release it to everybody. So this is our design goal for not only our CI, but I'm kind of hinting at a release process as well with this picture. Now, how can this all be solved? And specifically, how can it be solved with choosing a certain continuous integration application server, like Bamboo or Jenkins? We could go with an approach called a pipeline. A lot of people are familiar with this concept, especially if you're a Jenkins user. This can also be visualized if you want in Bamboo. Just because Bamboo uses plans and stages doesn't mean that we can't visualize that there as well. So if I took my design picture from the previous slide and put it into a pipeline, this is what it would kind of look like. Where we compile a unit test JIRA, we would run our functional tests, then maybe we would run our WebDriver UI tests after that, run our platform, our database, and operating system tests. Then we deploy that to some QA and then to our internal production server, and then finally we'd be releasing that to customers. Now, one issue with a pipeline, a serialized pipeline like this, is that once you run the first and second kind of parts of this, for this entire string to finish, they would have to wait for this entire pipeline to be done. I don't want to do that. As mentioned in the previous slides, I'm kind of starting to look at that frequency question. Now, this is a good basic design, and if you're doing this, I think it's still a very, a solid design. It's going to still help you accomplish your mission, but I want to do it faster. Putting this into Bamboo's perspective, one step at a time here, to get a little bit more threading and speed with that pipeline, I'm going to just put this in a vertical approach here. Again, we're doing kind of the same steps, but now I'm launching a lot of things in parallel, like my functional tests are running all in parallel along with my WebDriver tests. All of my database tests can launch at the same time as well in what's called another stage of Bamboo. And finally, once all that information is done, and I like it, and it's green, I want to automatically deploy JIRA to a QA server. And then finally, I can, if I want to, deploy it to production. So I'm getting a little bit of speed with some parallelization using Bamboo stages in this picture. How does that apply directly to the JIRA continuous integration build? Here's just a very basic picture of what that looks like. So again, I compile a unit test, and then in my second stage, I'm launching all of my test builds. Now, if something happens there, my entire result for that plan in Bamboo is going to be red or green. One result, one place for my developer to go look at the results, instead of having 20, 30, whatever places of results to go from if I didn't have this in one Bamboo plan. Here's how it actually looks like in Bamboo. Along the left-hand side, you can see all of the test builds that I'm running in one stage. And at the top, looking at produce JIRA artifacts, that's my compile unit test stage. Now the developer can come in here and quickly see at the bottom of the screen that, hey, test pie chart failed. And maybe I put in a change here that made it fail. I've got the stack trace in the middle there and kind of a nice summary, a nice little dashboard for me as a developer to go to pinpoint what happened with this build. Leveraging CI into a release process now is fairly simple. And I kind of put in a nice design here of being able to bridge this from CI into some kind of a release mechanism. So in this picture, I'm using what's called a parent-child relationship in Bamboo. In a parent-child relationship, if you're using the same source control URL, it's going to keep the same revision between the two builds, the two plans. So think of it in Jenkins as two different pipelines using the exact same revision number that are tied together. So in the first one, the top part, the parent plan, is my inner loop CI process, where I'm compiling and launching all of my tests in parallel to give me the speed I want. The child plan now, if that goes green, if that's successful, I'm going to deploy my Maven snapshot artifacts up to my Nexus repository. And this is key because these snapshots are going to be consumed by that outer loop CI process that I talked about. All of those database tests, all of those, the performance tests, the operating system tests, they're going to consume the product of this deploy snapshots Maven artifacts phase here. And that's key because I don't have to recompile. I can just consume that down from Nexus and launch. But this child plan with the same exact source control revision with my repeatable build process, I'm going to do one further thing. And this is where I can now create a release tag or a release branch as a manual stage. So Bamboo is going to wait for input on whether or not to launch this manual stage at the bottom. And this is going to kick that process off. I'm going to create the branch from that same revision that my continuous integration build and my parent plan, the same revision that when it passed. What does this mean for me? I do not need any kind of code freeze. I've done the appropriate plumbing here to be able to create the branch, create the tag, and all that business. So I don't need to wait for a quiet upstream source control server in order for me to do a release. We don't have code freezes, and I feel that code freezes are expensive. They can last from maybe 2 hours to 2 days, depending on what kind of company you are. And what I'm saying here is let's remove that, and let's get those the savings right now. So how does this look? As a release coordinator, at the top right-hand side of the screen are little green circles. These are the results of previous builds. I can now navigate in the past and pick and choose which build that I want. I can navigate to it and then go down to the Create Release branch and hit the play button on that manual stage. That's highlighted in the red box right there. Now to help me out as kind of release coordinator, I've got some more information on the build results summary here that's showing up. Number one is I can see all the code changes that went into this set of changes for this build. I can also look at the JIRA issues that are linked up if my developers appropriately put in the JIRA issue in their commit. So I've got a nice little dashboard here to see what kind of went on so I can navigate to the right build that I want to create my release from. Once I've got that process done, I've got a separate build that actually performs the release from that tag and that branch that I created now, with now the updated POM versions of the appropriate JIRA release number. I want to rebuild it. I want to retest it. So what I'm doing here is not only building JIRA, but I'm testing all of the installers, making sure they built appropriately. Nothing went wrong. I'm doing some smoke tests against them. I'm also launching all of the functional tests that I did in CI, because it's the same revision number, remember. All of these functional tests should be green. And if they're not, I've either got an infrastructure problem or maybe a flaky test, but I really do expect all of this stuff to go green. And then finally, I've got some later stages to kind of do my release finalization activities. These are kind of Atlassian specific types of pieces that we need to do to prep it for consumption for the customer. All this can be leveraged from Bamboo as an orchestrator of my release process. Now, one thing that I also did with the JIRA release process is create a way of tracking for the release coordinator. So I'm using JIRA to release JIRA. It's kind of a neat little coin name there. But basically, I take JIRA as an issue tracker, and it really helps me become the release coordinator of everything. So I can create a release template issue in JIRA and give it a nice description of what it is. So this is kind of the overall release orchestration issue. I can then assign this to a designated person. So this might be, what we do in JIRA is we rotate the release coordination activity with developers. So I might assign this to developer A one week and developer B the next. Because we are cloning JIRA issues from this template issue, all of my historical issues that I've cloned are showing up now on issue links with the clone by facility. This is neat because I can historically go back and look at all of my previous releases of JIRA. And then I can create a number of subtasks for all the activities, all the steps that I need to do to release JIRA. Now some of these are automated. Some of these are automated within the build that I showed you, the release build that I showed you on a couple slides ago. But it gives you just kind of a look and feel. I can assign each subtask to different actors to perform during the release process and kind of manage that, be a central place to go for information about how this release is doing. One little neat bit about our release process with JIRA is we automate the release notes. So all of the JIRA and Confluence release notes on confluence.atlassian.com that customers can look at to get information about the release, this is done through a Python script through Confluence XML RPC and using JIRA JQL to display the query on the page for all the issues related to this release since the last release. The big deal here is my tech writer saves a lot of time creating this page then. They go out to Bamboo, launch a plan, and it's already done for them as a template, and then they're able to go make tweaks to it if they need to. And here's kind of how it looks. We've got a general template release notes, very small, but then at the bottom of the page we've got the JIRA JQL to bring in all of our issues for this release. And that's the JIRA release process. So we've kind of gone from continuous integration, looking at it, looking at a kind of a helpful tips on workflow, not only how to structure CI, but also to leverage that, bridge that into a release process. And finally, how do we help with our release coordination of that material? What are some techniques there that we can do? Now this is all great, and that design is wonderful. It's done really well for us. There's certainly other things that I think we can do to make it better. And it's not the, it may or may not be the best thing for your company, but I think they're really good ideas, and maybe they'll spark something for you on things you can do. But with all that, we need to run all of that CI, all of those release builds somewhere, okay? And that's where we come with the infrastructure part. We want to be able to make a highly consistent build infrastructure. We want results that are going to be the same, from the same source control revision. If I run that 20, 30 different times, I want the results to be the same. I want flakiness. I want to have that infrastructure be repeatable. So let's say I need to add more nodes or replace nodes in my infrastructure. I want to be able to do that quickly and have it be confident that that's going to be the exact same as my previous or existing nodes that are out there. I need to be scalable because, and that's especially for my internal use, we're running a lot of builds here and a lot of threading for CI, so I need to be able to, with the repeatability process, be able to scale this quite nicely. I need to change it. Well, everybody probably needs to change their build infrastructure because your requirements change, your product grows. It will need a new version of the JDK. It might need a new version of Postgres database. Who knows? We need to make change to those systems, and how do we do it efficiently? And finally, we want to, of course, be cost effective. We want to have our IT managers be very happy with us, okay? And we want to keep this within reason for cost. At Atlassian, let's start with all of our Bamboo build servers, where all the CI and releases happen, all the magic of how our products get into the hands of all of our great customers. We've actually sharded into a number of different Bamboo build servers. And we've broken it up by families. So our JIRA family of development, our Confluence family of development, our DevTools and On-Demand family of development. We've sharded this out for a few really important reasons. Number one is we've got just a massive amount of builds that are happening on each of those build servers. Each family just needs it for the scaling of their CI system. We run at least 100 agents on each Bamboo build server. So we're maxing things out from a supportability standpoint of Bamboo. Second of all, think about if you're an IT manager that has a number of different segregated development teams and you need to bill out your infrastructure, your services to those teams. This might be one way of doing it with a sharding. So you can separate and segregate people so that you can actually bill their time appropriately or that infrastructure appropriately to those groups. And finally, it just makes it a lot easier for all of my developers that are in JIRA, for example, to go pinpoint where all their builds are at. Instead of having 500 builds on one Bamboo server, it's a lot easier to go look at a Bamboo server with only 150 to 200 builds than 500. And finally, on the left, I've got a staging server for my team. This allows us to test out in a production-like environment any changes that need to go out to our production Bamboo servers and their appropriate remote agents. Each Bamboo server is connected to basically two different types of infrastructure. Number one is we have core at the bottom of the page. We're listening KVM there. We've got a number of virtualized KVM Linux agents running on hardware at our data center. This gives us our core build infrastructure platform. This is what most of the builds in general will be using as a software stack, as an operating system. Taking this now into the cloud, we use Amazon EC2 on the top of the screen to not only keep that same core build system in the cloud for scalability factor, but we also have all of our variants that we test in. So if you remember in the JIRA outer loop CI, we were testing the databases, testing the operating systems. This is where it all happens. We find managing that in Amazon EC2 to be fairly efficient. And we've got all the nice plumbing there to make that easy and quick and automated. So this gives us natural resiliency. What happens if certain hardware nodes at my data center falter? They can be picked, all that traffic and need can be picked up in Amazon EC2. And just like vice versa, if Amazon EC2 has issues, has connectivity issues, for example, which they do once in a while, it's fairly rare these days, we can really still have this core set of build infrastructure where we can get by on fairly well. Now, because Atlassian products are highly integrated, if you purchase Bamboo, for example, you'll probably be interested in maybe using JIRA as an issue tracker. They integrate really well. We leverage Maven quite a bit with dependency management for when we develop the software. So we've chosen to go with Nexus as a repository manager, an upstream repository manager. This has done quite well for us, and we're actually one of the biggest Nexus instances in the world. But we're also a global development staff. So Nexus can give us a power as well, and for each of my geographies, we set up a Nexus repository. So Nexus repository proxy, so that if I deploy up my JIRA Maven artifacts, if I decide in San Francisco that I need those artifacts, only one of the developers are going to have to spend time downloading them through the proxy. Each subsequent request of that artifact then is very quick. That nice caching happens. So that's very key, and it's a nice design. If you're a global development firm, this could be a nice idea for you. And certainly because we're leveraging Amazon EC2, we've also installed Nexus on Amazon EC2 for all of those instances there in the United States that we have on US East. So we've got all that wonderful infrastructure running. We've got at least 100 remote build agents per Bamboo server running. What happens when we need to change anything? Well, I'm just going to run you through the process itself and a few of the technologies that we use. So let's start with JIRA. Let's create an issue in JIRA for that change. We want to document the change. We want to communicate the change. So I'm going to add some sort of capability to my remote agent. This is a very basic example. We're also using Kanban on my build engineering operations team so that we can focus on that work in progress. So I can go out to my Kanban board in Greenhopper and select the issue and drag it across to in progress. This allows everybody else on my team or even external teams to take a look at what I'm working on at any given moment. So it's a very nice communication medium. It's easy for me as the engineer to pick and choose which issue to work on next. Now, when you think of any kind of infrastructure, the operating system, the configuration, the services, the packages that need to be installed on that system, all of this can be visualized in either scripting. A lot of people might have scripting to automate those machines and update them. But we actually use a technology called Puppet, and Puppet's really becoming the popular configuration management tool, along with things like Chef. One thing, if you notice through this, through Summit 2012, is that you've heard some people talk about it. So what I want to say about this is, if you're not using configuration management, please take a look at it. It's certainly a best practice piece to go with, and whether it's Puppet or not, I don't really care, but we have had a lot of good luck with Puppet itself. Puppet will then, we can design and we can code basically our packages, our configuration, our services into this Ruby-like code base, and we can basically put everything we want in there. So we build out a base operating system, and then we run Puppet and its modules on top of that, and it's going to populate, install the right packages, run all the right services. This is key because it's also going to do one more thing for me. It's going to we're not just going to install stuff with it. We're going to make sure that my system doesn't change. So if a developer decides to SSH into my build node and starts to play around, and I've actually done this myself, and decided to rm-rs/opt or something wild like that, Puppet's going to come through and say, "Oop, nope, that's not right. That's not in my manifest. That's not in my recipe," and it's going to fix it for me, or attempt to fix it for me with a source of truth. Puppet also has kind of a style validation with Puppet lint. So this is your check style for Java developers. And we are also going to leverage Cucumber, some behavioral testing. Once we've done our Puppet run, how does the system look? Just as an extra step outside of Puppet to make sure we're good to go. And finally, we're going to do another development practice of using code reviews. And let's use our favorite one called Crucible. So Crucible I like in particular because of inlining of comments. And what this means is it'll give me a diff of my change set, and my peer reviewers can go in there and within this change set put in a number of comments to really pinpoint that feedback for me, and maybe even giving me an exact example of what they're talking about. I will know precisely which part of the change set that I have done that they're talking about. It's an extremely efficient process. Once I'm done with that, I'm basically ready to roll this out. So let's go ahead and do that. A very basic process. Remember, we've got a staging server and 3 family Bamboo servers to roll this out to. So we've got our existing Puppet code on our Puppet master pointing at our staging and our 3 production servers. We can then clone down the same code base and point over my staging server. Now, the staging server is hooked up to nodes that are exactly like my production environment. So I can run it, launch my Puppet run, and just see exactly what it's going to do. Because this is just giving me the confidence now that it's not going to break. Once that's done, I can schedule in my production servers, link them up to the new code, and go. And that's my definition of done for putting out a code change through Puppet and really managing my infrastructure well with confidence. The next challenge for us going forward with Atlassian on the development teams is really a scalability issue. We want to provide more features. We want to provide more fixes. So we've hired a bunch of developers to help us out with this. And we keep growing. This is great. But with more people and more features and fixes means more commits per build. So instead of having maybe 5 commits on a continuous integration build, I've actually been looking at like 40. And that starts to be hurtful because if something goes wrong there, it's a lot harder to troubleshoot. And more developers are affected by that build going red. More developers might be looking at that build if it goes red. So we're going to look at team branches with DVCS. This could be feature branches or any kind of submodule of your product. A subteam could be using one branch off of your main line to be able to do their development work, their primary development work. So each of the circles at the top represents a subteam in JIRA. And so we'll have one branch going per Agile team. And we're going to have a copy of our CI process and going on each of those branches. What we want to be able to do then is once the continuous integration builds go green, we want to automatically and frequently merge that material down without any interaction. Now, you don't have to do this. A lot of people like to use an actual integrator, maybe a team lead, a person that does the merges. You can still certainly do that in this design, okay? But we want to do it automatically because we do test. We have a lot of automated tests. We're fairly confident, and we're happy with doing that with some kind of a tooling for us. Now, if something goes wrong, if one of those branches has some bad commits in it, breaking a bunch of tests, they're isolated. So only one subteam is going to feel the immediate feedback of that problem. All the other subteams are going to keep building. They're going to keep going green, hopefully, and keep merging to the main line, the master. So this helps that master be more green. And what does that mean? It means that we can release from it at a higher frequency rate if we want to. We're going to leverage Bamboo's feature to do this. Bamboo has an I8 feature now with Bamboo 4.1 using the gatekeeper functionality. So again, if my plan branch that's sitting out there with its CI goes green, automatically merge that down to master. So we're leveraging our CI app server to help us out here with our source control merging and management. For a lot of people on SVN, I think they want to do this. I wanted to do this at my previous position, and it's not always easy. So ponder maybe even going to DVCS, going to Mercurial, going to Git, to have some of this functionality at your disposal. It's going to help you out and make your lives a lot better. So I just wanted to thank you for your attention. It was a great story. These are ideas that you can go with. Again, I don't mean to say that these are ideas that you have to or you really have to go with, but maybe they have spawned some interest in this area. Take a look at your CI. How can I improve it? Do I need to run my builds all the time? Can I use my CI to be able to bridge into a release process? How can I coordinate my releases better? And then finally, how do I bring the infrastructure to play that can make that all happen? And certainly at scale to make your lives be able to release your software on a faster basis. Thanks a lot. I'm Bryce Johnson with Atlassian. Hope to see you around.